All right, so let's let f of x be 3 over x plus 2. And the graph of f is given in red here. Let's say we want to find the derivative of this function at x. And what we're going to show in the next slide is that the derivative of this function is given by negative 3 over x plus 2 squared. So f of x is 3 over x plus 2. So the derivative is this limit. So let's plug in f of x plus h. And it'll be 3 divided by x plus h plus 2. And then f of x would be 3 over x plus 2. So this is the limit that we need to compute. Hopefully you have seen such limits already. So basically then we have to combine these two fractions into one, and this 1 over h here we're gonna separate that out first. So I'm writing this h 1 over h here, and then I'm trying to combine these two fractions. One way to do that is that you make the denominators of the two fractions the same. So I multiply this fraction. I multiply the numerator and the denominator of this fraction by x plus 2. So I'm going to get 3x plus 2 here divided by this times x plus 2. And I multiply the numerator and the denominator of this fraction by this denominator here. So I get 3 times x plus h plus 2 over x plus 2 times x plus h plus 2. Okay, now the denominators are the same, so now we can just subtract the numerators. And if we do that, so we're subtracting this from this. Now this is 3x plus 6, and this is 3x plus 3h plus 6, and you're subtracting. So this is what we get. We can cancel out the 3x, we can cancel out 6. Now we only have negative 3h in the numerator, but then I can cancel the h with the h here. So we have negative 3h now, and this 2h will cancel out. And then we have negative 3 over x plus 2 times 3x plus h plus 2. And now as h goes to 0, then we get negative 3 over x plus 2 times x plus 2, which is negative 3 over x plus 2 squared. We obtained that the derivative of the given function is negative 3 over x plus 2 squared. So let's now say that we want to find the equation of the tangent line to the graph of this function at the point where x is negative 1. So what is that point? Well, when x is negative 1, what's the y value? Well, it's going to be 3 over negative 1 plus 2, which is 3. So we want to find the equation of the tangent line to the graph of the function at the point negative 1 comma 3. And so we know that the slope would be given by the derivative at x equals to negative 1. So the derivative when x is negative 1 is f prime of negative 1 is going to be negative 3 over minus 1 plus 2 squared, which is going to be negative 3. So what we find is that the slope of the tangent line to the graph of the function at negative 1 is negative 3. So now we can write down the equation of the tangent line. So here is the point negative 1 comma 3, and the equation of the tangent line here would be the following. So since I know the point, I know the slope. We just use the point slope formula again. So y1 is 3, x1 is negative 1, slope m is negative 3. Plug those in, and then simplify. You get that the equation of the tangent line here is y is equal to negative 3x. Okay, so let's do another example. So here we have the function f of x is equal to root of x plus 4. Again, we want to find the derivative of this function at x, and what we're going to show is that this derivative is equal to 1 over 2 times root of x plus 4. So let's compute that. So here's the function. Here is the limit that we want to compute then, because this is this is f of x plus h. F of x plus h would be root of x plus h plus 4, and this is f of x. So I'm pretty sure you have seen a limit like this in the previous some of the exercises you have done for some of the previous sections. So to compute this limit, what we do is we multiply and divide this fraction by the quantity, the root of x plus h plus 4 plus root of x plus 4. So this quantity in red is called the conjugate of this numerator. So we're multiplying and dividing by that. So this is just in fact 1. So it doesn't change the quantity here. Now, as in doing that, what's going to happen is that we will be able to get rid of the root in the numerator, and so let's see what's going to happen. So when you multiply these two numerators, you see this times this will give you x plus h plus 4. This times this is going to give you minus x plus 4. And then when you multiply this, when you multiply this two, and when you multiply these two, they cancel out. So this times this cancels this times this. So this is all you get. In the denominator, we're not going to try to do anything. We'll just keep them as h times that. And then you can see that we can simplify the numerator, and we get h divided by h times this quantity. H cancels out. So we get 1 over this quantity, and then when we take the limit, when you plug in 0 for h, we get this, and this is, we see that 1 over, so I get root of x plus 4 and plus root of x plus 4, so that's 2 root of x plus 4, and so that is the derivative of f. Okay, so now let's find the equation of the tangent line to the graph of f at the point where x is negative 3. Well, when x is negative 3, what's the y value? Well, f of negative 3 would be, remember, f of x is root of x plus 4. So f of negative 3 would be root of negative 3 plus 4, and that's 1. And so the derivative is this. So the slope would be f prime of negative 3, and f prime is this, so f prime of negative 3 would be 1 over 2 times the root of negative 3 plus 4, which is half. So the slope of the tangent line at this point is half. So we know the point is x is negative 3 and y is 1. And so in the point slope formula for the line, if we plug in the slope half, y1 is 1, x1 is negative 3, and so we do that, we simplify that, put it in the point slope formula. This is what we come up with, and so that's the equation of the tangent line at the point negative 3 comma 1. Okay, so this is it. So this is the end of this video, and also the end of videos in this series. So what we have done in this and the last few videos is we defined the derivative of a function. we gave two interpretations of the derivative in terms of slope and rate of change, and then we computed the derivative of a couple of different functions, and used the derivative to compute slopes of tangent lines. Okay, so um, um, so what's gonna come up in next is that we will derive a bunch of derivative formulas, and then use them to compute derivatives. Okay, so I hope to see you in the next video.